Imagine two similar cars from the same manufacturer, both designed for performance, but one has a crucial engine part that is completely missing, while the other has a version of that part that is simply less efficient. This analogy helps us understand why Duchenne and Becker muscular dystrophies, while related, present very different challenges for the body. Yes, Duchenne muscular dystrophy, often referred to as DMD, is generally more severe than Becker muscular dystrophy, or BMD. This difference in severity stems from the fundamental issue of how the body produces and uses a vital protein called dystrophin. The core reason for this difference lies in the dystrophin protein, which is essential for healthy muscle function. In Duchenne muscular dystrophy, the gene mutation leads to a complete or nearly complete absence of functional dystrophin. Without this protein to protect muscle fibers, they become very fragile, easily damaged, and are eventually replaced by fibrous and fatty tissue. In contrast, Becker muscular dystrophy involves a mutation that results in a partially functional, but often reduced, amount of dystrophin. This allows for some muscle protection, leading to a slower and less severe progression of muscle weakness. Understanding this distinction helps families and medical teams anticipate the course of the condition. For Duchenne, symptoms typically appear in early childhood, often between ages 2 and 3, and progress relatively quickly, impacting major muscle groups and eventually the heart and lungs. For Becker, symptoms usually emerge later, sometimes in adolescence or even adulthood, and progress at a much slower rate, often allowing individuals to retain ambulation for a longer period and experience a milder impact on cardiac and respiratory systems. A key diagnostic differentiator that genetic testing reveals is whether the dystrophin gene mutation causes a frameshift in the genetic code, leading to Duchenne, or an in-frame deletion, which typically results in Becker. This precise genetic detail directly correlates with the amount of functional dystrophin produced and, consequently, the clinical severity. It is the molecular blueprint that dictates the body's ability to maintain muscle integrity over time. Knowing that Duchenne muscular dystrophy involves a complete absence of functional dystrophin, while Becker muscular dystrophy allows for some partially functional dystrophin, provides crucial insight. This knowledge helps to explain why Duchenne presents with a more aggressive and earlier onset of muscle weakness, alongside significant heart and lung involvement, while Becker typically shows a slower progression with a milder impact on daily life. This understanding is vital for informed care and support.